Morning students, thank you for joining my chemistry class, especially for Indo module. The second meeting we are going to discuss about the topic, the quantitative composition of substances. The actual mass of an atom is very small. Take an example, atom fluorine. The mass of atom fluorine is 3.16 times 10 to the power of minus 23. So it will be very convenient to describe an atom mass by comparing with the mass of another atom. Carbon-12 is used as the standard atom against which the masses of other atoms are compared. So, the relative atomic mass is the average mass of each atom compared to 1/12 of the mass of carbon-12 atom. The relative atomic mass of elements is calculated from two things. The first one, the mass number of its isotope, and the second one, the abundance of this isotope. Naturally exists with two isotopes. The first one is chlorine 35 and the second one is chlorine 37. So, to get the relative atomic mass of chlorine, it means that you need to calculate by multiplying the percentage abundance of chlorine 35 with its atomic mass plus the percentage of abundant chlorine 37 with its atomic mass. In the slide, I have already shown you the working step of how to get the relative atomic mass of chlorine. Molecular mass means that the sum of the relative atomic mass of the atoms in the element shown in the formula. To calculate the relative molecular mass, it means that you need to count how many atoms of each element present in the chemical formula. The second thing that you need to do is you need to add together all the atomic relative values for all the atoms of each element present. So, in the slide given, I have already shown you how to calculate the relative molecular mass of ethanol. Ethanol consists of three types of atoms. The first one is carbon, hydrogen, and also oxygen. There are 2 carbon atoms, 6 atom hydrogen, and 1 atom oxygen. So, to calculate the relative molecular mass of ethanol, it means that 2 times relative atomic mass of carbon plus 6 times relative atomic mass of hydrogen plus 1 times relative atomic mass of oxygen. To be detailed, you may take a look at the calculation mathematically of the relative atomic mass of ethanol in the slide given. Are very small and have very little mass, but the number of atoms in 12 grams of atom carbon-12 is very huge. Now, it is equal to the Avogadro constant, which is 6.02 times 10 to the power of 23. So, to get the number of particles of substance, it means we can calculate by using two things. The first one is the Avogadro constant. The second one is the amount of substance in mole. So, the formula to get the mole number by using Avogadro's number is mole equal to the number of particles divide 6.02 times 10 to the power of 23. Now, in the slide given, you will see how to calculate the mole of sodium chloride in the 3.61 times 10 to the power of 24 of sodium chloride. The equation in the slide shows how relative molecular mass and also number of moles and mass are related. So, number of moles equals to mass divide relative molecular mass. Now, in this slide given, I show you how to get the moles of ethanol in 9.25 grams of ethanol. So, it means that to get the moles of ethanol, you need to divide the mass of ethanol, which is 9.25, divide to molar mass of ethanol, which is 46.08. So 9.25 divide 46.08, you will get 0.201 mole of ethanol. Each element in compound is always in fixed composition or percentage. When the percentage is expressed by mass, it means that It is mass percentage composition. It is the percentage ratio of the total mass of an element to the total mass of the compound. In the slide given, I will show you how to calculate the percentage of atom hydrogen in sulfuric acid. Sulfuric acid has three kinds of atom. They are hydrogen atom, and also sulfur atom and oxygen atom. Now, to calculate the percentage of atom hydrogen, it means that you need to multiply the number of atom hydrogen in sulfuric acid times the relative atomic mass of hydrogen per the relative molecular mass of sulfuric acid times 100%. So 2 times 1.008 per 98.09 times 100%. So you will get the percentage of atom hydrogen in sulfuric acid, which is 2.055%. The empirical formula of a compound is the simplest whole number ratio of the atoms of each element in compound. It is determined by using data from experiment, and therefore it is called as empirical. Molecular formula can be converted into empirical formula. Take an example. Here is glucose. Glucose molecular formula is C6H12 and O6. So the empirical formula will be C1H2 and O1. This is because we can divide each number in a glucose molecule with 6 to make a simpler whole number ratio. The last topic that we need to discuss today is balancing chemical equation. We can balance the chemical equation by looking at the number of the atoms of each element at the left side of the chemical reaction should be equal with the number of atoms of element at the right side of chemical equation. Now, there are 4 steps that we use to balance the chemical equation. The first one, you need to write down the word equation. Here, magnesium plus oxygen to be magnesium oxide. The second one, you need to write down the chemical formula for each reactant and also product. Magnesium become Mg plus oxygen become O2 to be magnesium oxide become MgO. Then, third, you need to balance each atom separately. Now, the result of balancing atom of magnesium is 2 magnesium atom plus oxygen to become 2 magnesium oxide. Then, after you balance the chemical equation, you need to write down the physical state for each of formula, whether it is solid, liquid, gas, or aqueous. This is the end of my learning video, and thank you for your attention. If you have any further question, you may ask me. So, goodbye.